mugging, and it had that on it. I still have it in my office, and a big cake, and that was on the cake. So I just turned it around from biology 1010 to something new. So you're going to see PowerPoints will vary in things because PowerPoints are getting crossed back and forth between anatomy and some of their phys. I find as we go into it, PowerPoints that come with this series of this book really, really stink. So I do a lot of modifying to them because they're awful. They take for granted you know, or you don't know. And if I just stick it up there, you're going to be, you got that? You'll be like, so it's like, we don't do that, all right? If you ask me a question about a PowerPoint, I just don't read it back to you, like other instructors do. Because if they're reading it back to you, that means they don't really understand it either. So I interpret it for them. And some of them will be words. Right? And we all know how to read, so I'm not going to read the thing to you. But I will say to you, did you get this out of all that information? Because that's the only key thing that's out of all that crap that they stuck up. There's like 3 key points. And I bring them out for you. And that's all I would ask for, the 3 key points. I'm not going to ask all the BS that goes with it, okay? So here's your course. So there's the book, lab book, yay, there's your code again. You get 3 written exams, 2 lab exams. The lab is worth like 1 test. So unlike anatomy, you gotta do better on the practical. You still will be okay. Now, some of you, I think I have both sections for it. Because then we have a lab on Monday,
Yeah.
and then Tuesday morning is the other, so you have it for everything. Okay. And the old Tuesday don't, they have different lab instructors. So he did live, so.
Whitney hates it.
Huh?
Whitney hates it.
I know she did. Who they put her with is like, I feel bad for her too, but I'll shut up. Okay. So you will get 2 practicals. So the point is you have me. You do correctly, then shame on me. Because you get handouts in that. And if it's on that handout, I can ask you about it. That's why you pay attention to it. But in every lab, and they'll always have you before, I give you like a good 20-minute introduction to what we're doing and show you what we're doing. So you know what you're doing, so you don't sit there lost. Like, but then you get some who come in a half hour late, and in that case, they say, well, I should lab on this. They'll explain it to you. I look for one lab person, especially I get some that have had this stuff. You should become the lead in your group for the people who never had it before. Because you do know more than they do, especially in the lab. You're going to find the lab comes right back to you very quickly and very boring. That's the problem when you take a course again. You're going to take for granted you know it, and you kind of don't know the detail, and you're going to mess up the test. So you still have to put the study time in. More to keep it here, not to understand it, if you get what I'm saying. Because if you don't, you're going to hurt yourself again. You'll pass, but not what you want. So that's a little advice when you're doing it again. It was different. You've had both classes, anatomy and phys, so it's the same thing, just smashed together. So we get into this crap here. So when we get into, first of all, anatomy is the study of the parts. Physiology is the study of how it works. You know, how's the part work? And when I did anatomy, I always would bring physiology into it. Those who have, you're going to see that some of it don't change that much because I kind of always went into the detail of the sarcomere and all that anyways in my anatomy. Because you need to understand that. Because if you don't, you know, who cares? Or, well, why does it stay standing up? Looking at the 4 legs on the desk. Well, if we put 3 legs there, how would it be? Well, it would be wobbly. Okay, so you're understanding a concept. Because I look at it this way. If you understand it and then just memorize it, then you never forget it. Because this stuff is going to come back and bite you right in the butt when you get into nursing. They're all gonna, and there, they take for granted you know it already. Especially cranial nerves, and especially the heart. That's why I put a lot of emphasis in that. We've met with the nursing department. What do these kids need to be ready? Are we giving them the right information? So, in theory, even though these are bio-core, they're really allied health classes. They're kind of designing them for you guys to succeed going to where you're going. Not like a true biomed. So there's the grooves and the microscopic. You know, Brooks is looking at the big structure. Microscopic is going down into the cellular. So it's normally in anatomy you stay kind of in emotional, but then in physiology, well, we deal with it. Okay? We deal with it. You know what's that important. So then you have, you know, so that's psychology, histology. So psychology is the study of the cell, histology is the study of the tissue. And you will have a lab where you look at tissues and identify them. So you will have a microscope lab where you do that. We're not really going to look at cells. That's like, well, you know, we're not cellular bio. So we're not really going to do that detail. We'll go through some of the cell parts and understand. So this first part of the course, the first 4 or 5 weeks is very similar as if we took cell biology. Then we're trying to shift away. So we got to give you a foundation. I got to make sure you understand chemistry, how molecules hook up together, how do things cross a membrane. We got to make you understand this stuff. And if you get an understanding of that, then physiology makes sense. That's pretty much what physiology is, are just pressure gradients and surface area. That's all it is. So you want to realize all our body's designed to maximize its surface area to get the greatest amount of absorption or secretion. It's as simple as that. And it's going to run pressure gradients. So it's going to try to run downhill if it can. So it doesn't exert any energy. If it has to exert energy and push uphill, then we'll talk about that. And we're going to talk about a product that you're going to get in your head, which is ATP. That's our energy source in our body. And the body likes to burn glucose to make this thing, and you're going to realize that. It prefers fats because it's more efficient, but glucose is more abundant and breaks down quicker. So the body rather utilize that. And you're going to see when we get into this, the brain itself primarily will burn carbohydrates, not fats, not proteins, carbs. So carb-free diets are not the best thing for the brain. So all these diet fads out there, you're going to start seeing as you start learning your physiology are a bunch of crap. There's no magic. The magic is less in, burn more. That's the magic. If your body burns 2,000 calories a day and you ding in 2,500 calories a day, we're going to gain weight. If you bring in 2,000 and burn 2, they stay the same. If you bring in less, you lose weight. There's no genius there. There's no magic pill, no nothing. So just keep that in your mind, okay? Then developmental, we do some of this as the embryo. So you learn how the body develops in the important phases as we go along. So we will do that. So it makes it interesting. So one big thing is the organization of life. How do we organize our life? So we see we have, so the most simplest unit in the world is the atom. It's the most simplest form of any type of energy in the world is an atom. The most simplest form of life is a single cell. And there are a lot of single cell animals that make you sick. Protozoa, bacteria. How about the virus right now?
China.
China. That's a variant of SARS. And so this is a nasty virus. Not yet. And they probably won't make it because it's not. It doesn't spread as easy as flu does, or chickenpox, or measles. But it can. Right now, they just discovered one case in the United States. It's in Washington State. But they isolated him right away and all the people he contacted. So that should stop it from moving. And all your major airports, when you would come in from this area of China, they're routed to these 5 airports, and you're going to be tested as you come in. If you have it, they're going to take you away. You're not going into the club. So you kind of have to do this stuff. Because they are going to probably announce it as a world epidemic. Probably within the next week. So when you get into healthcare, you get things all the time, emails from the CDC, the Department of Health in Rhode Island. You're right, the flu right now is a major epidemic in Mass, Rhode Island, and Connecticut. You've got 100 cases in Rhode Island with 2 deaths. And then we'll go in to show you how these things can take, how they can take a young person. It'll get into the cavities of the heart, cavities of the lung. And once they get in there, you're kind of like really screwed. Okay? So just think about that. So when we get a tissue means we got a bunch of cells that are working together with a common function. We created a tissue. Makes sense, right? Cells working. They don't have to be the same cell, but cells working with a common function create a tissue. Then how do we make an organ? Then we get a group of tissues working together with a common function. They make an organ. Then you create an organ system. A bunch of organs working together with a common function create a system, and then when you put all our organ systems together, you make an organism, which is us. And make sure you spell organism right. If you spell it wrong, it means something totally different. Okay? So, in other words, what they're using here, they use smooth muscle as an example. So they're showing the molecules. Atoms, molecules come together, we make an organelle, which are parts of a cell. That happens to be that bean-shaped organelle. What is that? In a muscle cell. What would that be? What?
I said shit.
Oh, you said shit. No, it's not shit. It's a mitochondria. So why is a mitochondria such a big deal? It's the powerhouse. That's where you ate. Is that what you're going to say? I'm sorry. Okay. So what's it doing then? How's it making power? What's it converting? You know? It's trying to convert glucose or any biomolecule into ATP. So you might ask, what does it do? Well, what's related to, you went to Foxwoods and you won $1,000 in chips. Are those chips worth $1,000? Yeah. But you leave and you forget to cash them in, so you go to a Stop and Shop and you buy groceries and you give them a $100 chip. And I say, oh, no. But it's worth $100, yeah. But it's not a commodity we can utilize. So you're going to convert the chips into dollars and cents. And then you can use that to buy things. Well, that's what the human body does. It can't use the glucose or the protein or the fat in the form it is, but if it converts it into an energy form, which is ATP, then the body can burn it. And that's what it does. It can burn that. Yes, glucose has energy, but in the form it sits, we can't use it. So we just convert it into dollars and cents that the body can burn. So that's the whole thing. So being this is muscle tissue, you're going to find muscle tissue in general have a lot of mitochondria. They're a high energy tissue. So that's what you're going to see in their cells. This is a spindle cell, so we know that's smooth muscle. So what we did, we took a bunch of these, and we put them together, and we created a tissue. Then we took a bunch of tissues, put it together, we created an organ, which is a blood vessel. Then the organ goes into the system, becomes an organ system with the cardiovascular. So what about bone? If I took your femur and put it there, where would you place the femur?
Organ
A what?
level?
Exactly, an organ level. Everybody understand that? That it would be an organ? Because does it fit the criteria of a bunch of tissues came together to make it? And the answer is yes. So let's say you would get asked about it. Give you something, I mean the hot, where would we put the hot seats?
Organ?
So if I give you the, osteocyte, come on. Osteocyte's gonna go with the cell. So you follow what I'm saying? So some of it is that simple. For some reason, students take simple stuff like this and make it hard. I don't know why you do that. It's just straightforward. If you understand the mechanism, how it built itself up, and then you know it. Okay, so being we have physiology now, usually anatomy would start here. Really here and go forward. But being with physiology, we start here. Yay. So, unfortunately, the first part of this course is like everything. And then requirements of life, well, to make this is common sense stuff. So that kind of stuff doesn't really get asked about because it's kind of stupid. What is the most important thing? The most important thing for you to survive would be, to bring in food, to metabolize it and be able to get rid of it, correct? What's the most important thing for a species to survive out of that list? Reproduction. If it doesn't reproduce, it's gone. So there's your variation between if this was organismal biology being physiology. And organismal, the important thing would be reproduction. And what are the only organs we can live without? Reproductive organs. You don't need them to survive, but you need them for the species to survive. So they take uteruses out every day, prostate glands every day, mammary glands every day. These things are removed from people. If they're removed on time, the person survives. So you really don't need it. But if I take your heart away, well, you're kind of like screwed. Or you just become a heartless being, whatever. So it's some of this common sense, maintaining boundaries. Well, even at the cell level, you have a boundary. You have a membrane that separates from other cells. Gives it its own identity. And the funny part is if I take a cell out of you and put it in a petri dish, it'll live forever and keep reproducing. But we put it in you and it dies. So that's one of the things they look at. What is it in us that makes cells die and do certain things, and why it's got an age restriction. And if you notice, the age, average age of living has dropped a bit. Not increasing, it's going down. And some of that's because of suicide. That's what's doing it. Not because of more cancer. Suicide. Because everybody thinks that cancer, what's the number one killer in the United States? What? He's the one on the right, heart disease. Cardiovascular disease outnumbers all your cancers, everything put together. Now, diabetes will lead to cardiac disease. So you put it there. But believe it or not, you hear, oh, cancer, how about your heart? Have a heart attack, it doesn't work good anymore. It don't regenerate itself. Does it grow? Yeah, it does, but it grows, probably takes 100 years to make one cell. So guess what? You're kind of screwed. They are doing a lot of stem cell research with it, especially on rats and things where they induce heart attacks in them. And then they paint the heart with stem cells, and within 48 hours it's back to a normal heart. So eventually that will be, so your generation of working in healthcare is going to see this big shift, where you're not going to be using so much drugs and things anymore. You're going to be using a new, stimulate their immune system, stem cells. Things of that sort to make people better. Where, the day and age I come out, no. Cut it out, hit it with this, and they realize the top 3 cancer research places in the world realize that for the last 40 years, we've done cancer wrong. Wrong, totally wrong. We targeted it, we cut it, we chemoed it. That was just hit or miss. We're using immune suppressants, immune stimulants. Let the body fight it itself is how they're treating it now. And eventually, by the end of this decade, because I watch a lot of things on it through Medscape, they should have cancer as a total treatable disease. They don't have it, because we can treat it. We can treat diabetes. Even AIDS now, look how much control they have over that. 20 years ago, this was it. They're done. They got new drugs that suppress the virus so bad you can't even transmit it. Because the body itself is holding it at bay. When you get into the immune stuff and we do AP2, you'll learn about how this stuff works, the T and B lymphocytes, how they work to control it, okay? So then the skin separates us from our environment. So we'll talk about the skin. It's an important thing. I think it's start to go slow when we slowly get into it instead of just destroy you on the first day. Responsiveness. Well, we have to have a system to be able to react to stimuli. Because if we didn't, we'd be dead. Imagine a wild animal has no reaction to stimuli like a rabbit. How long that would last out there in the wild? We'd go on the... Same with you. You don't know what's cold, you don't know what's hot. The body can't react to it. And what's most of the body's reaction? What type of feedback we need? Negative or positive? Negative. So does that mean you're negative all the time? It's not. Negative feedback means we move in the opposite direction of the stimulus. Positive feedback means we move in the direction of the stimulus. What do you think is a positive feedback in the human body? Not mental things. We're not talking about that. We're talking about physiological function. What would be an example? Anybody have an idea? Anybody around the baby? Did you just change your mind and it's not coming out? No. Once the process begins, it don't stop. And that uterus don't get tired. You get tired. The baby's getting worn down, but that uterus is boom, boom, boom. That's a positive feedback. It doesn't stop till it's done. And the other big one, blood clot. It also when the nerve first fires, it's positive feedback. Remember that? Then it becomes a negative feedback. We'll talk about that later. So those are two big key points in physiology. So most of us work on a negative feedback, meaning if your blood pressure is high, what's the body going to do? Try to lower it. Blood sugars are low, we're going to try to raise them. You follow what I'm saying? So that's negative feedback. We're moving the opposite of what the stimulus did. Okay, so that's what we mean by this. So it's not just, sticking a pin in someone, okay. No, breathing rate has to change. If I'm walking upstairs, my heart rate has to change. My respiration rate has to change. Your blood pressure has to change. Or you're not going to get oxygen to your brain. Follow what I'm saying? So that's different. That's a negative feedback. It's working away from the stimulus. We're going to break down food and be able to absorb it and make it work in us. But we have that. So in other words, we're covering all these systems. Then we have to utilize it. Metabolism. Metabolism to break down this stuff. Anabolism is synthesizing. So we're going to see we actually break down carbs and we synthesize. We break down fats and we synthesize. We break down proteins and we synthesize. The body has the ability to do both. That's your liver. So you have a liver. And not only is the liver the toxic, it also does all this. So it's amazing what the body, if you think about what the body can do and how fast it does it, you can't make a machine that can do that. Not even that. Comes close, but still not totally. The body, it's amazing what we can do. It's like miraculous what the body can actually do and how it works. And then we're going to get rid of it. So with urine, when you excrete urine, that's metabolic waste. That's telling me the cells are getting there. Unlike fecal matter, that's just unabsorbed fiber the body has no use for when it gets rid of. It's not the same thing. You know, I always think, and I remember when I was a kid, going back a long time ago, okay, half a century. Yes, you'll be there someday. If not, you'll die young, so it's not a good thing. So, my grandfather was sick, and he was dying, and he couldn't go to the bathroom. He was like impacted, and he was still had urine up to him. So I remember my mother or one of my aunts asking her, is that taken up for the other system? And she said, yeah. So you better never say that. Yeah. Like you have me for this cause. Yeah. How wrong was she?
Super.
Totally. It doesn't. Don't take up for it. That's metabolic waste coming from the cell. The other one's not. So how's it taken up for? It's not. Toxins are backing up in the body, in the GI tract, so you're going to get it out of there. But you follow what I'm saying? No, it's not taken up for. Unlike, yes, will the respiratory system help out the urinary system? It's like sweating. Yes, that's different. That's still metabolic. So never say anything like, oh my God. Just say, I don't know. But don't say, yes. You remember, what you say means something. You have a lesson to what you're doing. So if a nurse is checking you out and nurse goes, how are you going to feel? Like, shit, I'm dying. Right? You just walk in the room and show your face and smile, that alone makes the person feel better. Some of you, it's just natural instinct that you just walk with a smile. It's like, that's what I'm seeing you come to my room someday. It's like, and then, of course, reproduction for the offspring to happen. But growth, increase size of the body part. So you increase the size by hypertrophy. Does anybody know the difference between hypertrophy versus hyperplasia? Anybody know that difference? I've been answering everything. Let's go. So hypertrophy means it gets bigger in size. Hyperplasia is abnormal cell growth for no reason. You read that all the time on pathways. There's hyperplastic change of the epithelial cells of the cervix, indicative of precancerous change. It's hyperplasia. Why are these cells growing and they shouldn't? So there's your variation. Hypertrophy happens all the time. Eat too much, you get bigger. You weight lift, you get bigger. Pregnant, you get bigger. So there's normal one, and then there's the one that we really don't want. Like there's more of you as time goes on. You get on the scale, like there's more of me today. The world's lucky. See, the problem is, you gotta tell people, I'm too short for my feet. I should be 7 feet tall, but oh no, I shrunk. I didn't gain weight, I shrunk. So that's the better excuse to use. Let me see where you want this topped out. So we're a multicellular organism, all right, not a single cell. And we have 11 systems in our body. And through the course of the 2 courses, you will cover the whole 11 systems, some in more detail than others. This course here, you do a lot on bone, a lot on muscle, a lot on nerve. We end with nervous system. Then you continue the next course with the heart starts first. And you go into all the viscera. So there's a little difference, okay? So it's just giving you an idea of how these systems work together. Oh. So we need nutrients to come in to power this stuff, because it needs energy. And one key thing is, why is it so important for the body to sleep and rest at night? Why, if you don't sleep enough, does cut time off your life?
Never told me
That's
you're
another
21.
thing. Oh, why is eating too late not good for you? Not this isn't getting reflux, but why is not a good thing either? Because when the body goes to rest for that 6 to 8 hour period, that's when the DNA repairs itself. And fixes parts that are not working. When you eat way too late, like you're like you eat 9 o'clock at night because you work crazy, and then you go to sleep, your body's wasting most of the night breaking that down, digesting it, and not repairing it. When you don't sleep enough, again, the body's not resting to repair itself. This is going to make you vulnerable to disease. And that's not what's going on. And stress does the same thing. Stress, and I do show you a slide on from the endocrine, even though we don't, but near the end, showing how stress will kill you. How it screws up your organ systems where they don't shut down. And eventually you will end up a diabetic or hypertension, and eventually cardiac disease or maybe cancer. Or all the cortisol running around your body. But it's all these good things. But it's showing you all the interrelationship. There's the kidney filtering it away. Here's the GI tract bringing it in. Here's the heart moving it around. There's the lungs moving oxygen, carbon dioxide. So when you throw a wrench in one of these gears, kind of messes things up. Can live without the intestine, right? Nah. So what I'm going to do if we get some later is run attendance here, because if we don't, then, I have to get it done by certain dates, and I don't, because then I don't do it.